Hello and welcome back. Today we'll be doing question 5 from the 2008 math paper. Let's get started. The Millennium School has 1,000 students and 1,000 student lockers. The lockers are in a line in a long corridor and are numbered from 1 to 1,000. Initially, all the lockers are closed but unlocked. The first student walks along the corridor and opens every locker. The second student then walks along the corridor and closes every second locker, i.e. they close lockers 2, 4, 6, etc. And at that point there are 500 lockers that are open and 500 that are closed. The third student then walks along the corridor, changing the state of every third locker. Thus they close locker 3, which was left open by student 1, opens locker 6, and closes locker 9, etc. All the remaining students now walk in order, with the kth student changing the state of every kth locker, and this continues until all 1,000 students have walked along the corridor. Part 1. How many lockers are closed immediately after the third student has walked along the corridor? Explain your reasoning. Part 2. How many lockers are closed immediately after the fourth student has walked along the corridor? Explain your reasoning. Part 3. At the end, after all 1,000 students have passed, what is the state of locker 100? Explain your reasoning. Part 4. After the 100th student has walked along the corridor, what is the state of locker 1,000? Explain your reasoning. Pause the video to have a think, and once you're ready, restart to see if you were correct. Let's get started with part 1. Firstly, we'll notice that the third student closes the 3rd, 9th, 15th, etc. doors, and 6th, 12th, 18th, etc. doors are opened. Therefore, there are 167 doors closed and 166 opened. Therefore, the total number of closed doors after student 3 walks past is 501. Now, let's move on to part 2. Firstly, you might try to use an identical method to part 1, however, this would lead to quite a few cases. Instead, what we're going to do is we're going to find the lowest common multiple of 1, 2, 3, and 4. This, quite happily, happens to be 12. We now only need to look at the block consisting of the first 12 lockers, numbered 1 to 12. These follow the pattern open, close, close, open, 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 close, close, open, closed. In this pattern there are 5 closed lockers, and due to the nature of 12 being the lowest common multiple of 1, 2, 3, and 4, we can guarantee that this pattern will repeat itself down the line. Since 1000 is 12 times 83 plus 4, we only need to find the number of closed lockers in the first 4 lockers. That is, there are 2 closed lockers. Therefore, the total number of closed lockers will be 83 times 5 plus 2, giving us 417 lockers closed. Now, we'll move on to part 3. We'll notice that 100 has factors 1, 2, 4, 5, 10, 20, 25, 50, and 100, and therefore these will be the students who change the state of locker 100. Each pair of factors does not change the state, however, there is one factor that does not form a factor pair, that is, the factor 10. Therefore, 100 will end up open. From this line of reasoning, we'll see that only square numbers have an unpaired factor, that is, the square root of this number, and therefore, only square numbers will be open at the end. Now, we'll move on to the last part. Below 100, there are only 11 factors of 1000, and therefore locker 1000 is open after student 100 passes. This, of course, does not affect the fact that the locker will be closed by the time all 1,000 students have passed. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.